Okay, so this is the topic, technical agility, pitfalls and secrets of success. So I don't know if everyone here has seen me before, but I'm a technical agile coach and a conference speaker. I live in Gothenburg, Sweden, and I've just published this book, Technical Agile Coaching with the Saman Method. And I'm going to talk a bit about some of the topics from the book during the seminar. Do get in touch with me. There will be opportunities actually. I mean, you can send me an email, get me on Twitter. And after the seminar, I'm going to send out a link so you could book a short meeting with me if anything came up in the seminar you'd like to discuss afterwards. I'd be happy to have a chat with you. So you can use, there'll be a link in the mail that comes out afterwards, so you can sign up for that if you want to. So this is a picture that we at ProAgile use to describe the journey an organization makes towards agility. The steps that you might happen during an agile transformation, which is, it's never really done. You've got all these things that you need to think about. And one of the aspects of agility that I focus on, and some of my colleagues too, is the technical agile part of this journey. There's lots of other important things to get right as well if you're going to be successful with agile methods, to do with the organization, the leadership, the team structures and product management, all that stuff. All that is important, but today we're talking more about the technical side, although some of the rest will come up, I think. So on the advert for this session, I had this picture that I drew, which is basically three kind of common complaints that I hear in organizations that are, they want to be agile, but they're not quite getting there. So the first objection here is saying this code is really bad. Let's take a long break and rewrite it from scratch. And this is not what managers and the company leadership want to hear, because this means, stopping new feature development, investing a load of money in something they don't really see any benefit to. And this is caused often by the state of the code getting so bad that the developers really feel they can't make any progress with it. They can't add the features that they want to add. It's a mess. And that is a result of a long period of underinvestment, basically, in technical agility and technical agile practices. So that's one of the things I see happening. The next complaint here is about a team that's saying, well, we spent all our time fixing bugs. We're not writing any new features. And this is boring. And nobody likes this situation. And it's all too common. And again, it is a result of underinvestment in technical practices and code quality and stuff like that. Could some of my lovely assistants please mute whoever is causing the echo? Thank you. Then there's the third complaint that I hear is that teams are not able to deliver when they're supposed to deliver. They report we're 80% done, it's nearly there, or 90% done, but it never seems to get to done. And again, this is a underinvestment in technical agility. It's a bit the code and the setup and the team is not able to slice the features smaller and deliver them in small pieces. At a technical level, at the architecture level, they can't break the pieces down in a good way. So I think maybe these issues are familiar to you, and they're certainly some of the things that I come across fairly often. And it's some of the things that prompted me to come up with the Saman coaching method and write about it in this book. So the Saman method, which I'm going to talk about today a little bit, is a coaching method for working with software development teams to try and address these kind of technical issues. And I'm sure you may not know, but the word Saman is a Swedish word and it means together, because the basis of this coaching method is trying to get a team to learn together to apply technical practices better. So the focus of this coaching method is improving technical agility, basically. And it's not just me doing this. I mean, I've written the book, I came up with the name Saman, but it's not just me using this coaching method. I've got several colleagues at ProAgile who are also working this way. And there are other people around the world who are working in a similar way, although they might not call it Saman because I invented the name. But maybe they'll call it that sometime, we'll see. So that is basically an introduction to technical agility. And now I want you to turn it over to you. This is some breakout rooms we're going to have for 4 minutes, and you're going to discuss with these people you're going to meet, what technical challenges do you see in your organizations? Do you recognize any of these ones that I've presented, or do you have unique problems to yourself? You probably do. Everyone's problems are unique. So please explore that in your small groups. Please could my lovely assistants create the breakout rooms? But I hope everyone's had a good discussion about your challenges with technical agility. I think it's a very common issue for organizations that want to be more agile. So I'm going to continue talking about these kind of topics. So I showed this picture before, the agile journey, and it's there are lots of things that you need to get right. And I'm really interested in the organizations that are really, really successful with this. The organizations who've really got the technical agility working. And so this isn't, so I've got some information now about this research. This book came out in 2018, and it's largely about technical practices that the organizations who are doing really, really well and how they do things. And it's not just based on one organization, it's based on responses from thousands of people around the world over many years of research, finding out, well, how are they actually doing this, and what are the factors, what are the practices, the technical practices that lead to success. And the authors of this book are very well respected in the industry. Jez Humble and Jean Kim have written a lot of books in this area. Nicole Forsgren has a PhD in statistics and is the lead researcher here. So this is a really interesting source to find out about what actually works. And they found that it does actually matter. This is the main conclusion, I think, from the book. The biggest headline is that it really does matter how well you build software. In today's world of digital marketplaces and so on, it actually is crucial for your company's success that you get software development right. It's not just something you can kind of outsource. It's really crucial to your business. So that's really encouraging for us as technical people who build software. The second thing I think is really interesting about this research is that they found that you can measure somewhat objectively whether your development organization is good at software development. And they came up with some metrics that you can use to assess how well you're doing against others and how well you're doing against your past self, comparing numbers over time. So that's really interesting. I'm going to talk a little more about what those metrics are in a moment. But then, of course, the rest of all this research is working out what are the behaviors and technical practices that are driving better metrics that's leading to this success. Because this is the relationship they found, that companies have certain technical practices and behaviors that drive better metrics, that drive the success of that organization. And that is, I think, really interesting for us to look at when we're looking at all the technical challenges we have in our organizations. What are the best organizations doing? So before we talk more about those behaviors, I wanted to talk about these metrics. And I thought the best way to introduce these metrics was to have a poll where we could all answer the questions about determining what our metrics are. So I've got this Mentimeter poll, and I'm hoping that my lovely assistant is going to share a link to it in the
Yes, can you go back to the barcode so I can get the link again?
I put it in Slack.
Oh, you did it. Great.
I've shared it already.
Oh,
yeah.
Thank you. So,
yeah. So please start answering this question about deployment frequency. I think if you hover over the question, it gives you more details. So for the primary application or service you work on, how often does your organization deploy code to production or release to end users? Great. I see some people have started to respond to this. Yeah. Just wait for a few more responses to come in before I start to comment. Yeah. So this is the this is quite encouraging. There's nobody here admitting to only releasing less than every 6 months. So that's good. You must be doing something right. So of course, the deployment frequency most common, there's lots of different organizations here. So of course, it's going to be some kind of normal distribution, I imagine. And the most popular choice here seems to be releasing between once per week and once per month. But there are a few people who are deploying on demand multiple times a day, which is very impressive. It's a pretty impressive technical feat if you can manage that. So that's the first one of the metrics we're going to look at. Let's look at the next one, which is lead time for changes. So for the primary application or service you work on, what is your lead time for changes? And that is measured as how long does it take to go from code committed to code successfully running in production? So let's see what you make of this metric. And again, we're seeing a kind of normal distribution appearing here because you're all from different organizations. And it seems that, wow, there are a few people doing less than 1 hour. Yeah, there's actually, I mean, it's at the moment, the curve is not as normal as you thought. You know, there's quite a lot of people up there at the top end. So that's good news. But the majority of people here, I think, are still between 1 week and 1 month for this lead time, which is about the length of a iteration in an agile method. So maybe that's not so unsurprising for a seminar about agility and agile methods. Great. So I'm going to move to the next metric, which is time to restore service. So for the primary application or service you work on, how long does it take generally to restore the service when you have an incident or a defect in production that impacts users? So even if you're not delivering your software online, if you can still have a defect that impacts your users. So here we go. The early results are that it's pretty quick responding to these incidents. Just wait for a few more responses. Yeah, the normal curve is really skewed here. A lot of people getting it fixed within an hour, or certainly within a day. That's good. And even some people, less than 10 minutes. Now, that's a technical achievement, I would say, technical and organizational achievement, if you can get it less than 10 minutes. Very good. So, and then the next metric is about change failure rate. So for the primary application or service you work on, what percentage of changes lead to production, lead to a degraded service, i.e. there's a defect or an outage, and then you need to do a hotfix, a rollback, or a patch. So just to put that into perspective, if every time you put out a major release, you always put out a patch afterwards, a one patch before, and then that means that half of your releases are patches, which means that your failure rate is 50%. So this is like what percentage of your releases are patches or hotfixes.
Would that also increase the deployment frequency because you're shipping hotfixes all the time? I'm not saying that's a good thing.
Yes, it would increase your deployment frequency, I guess, yes.
Okay.
And this is, yes. So it kind of shows that you can't just focus on one of these metrics to optimize. You have to look at all of them. So yes, so this again, this normal distribution here is skewed towards the good end, which is good. So there's clearly a group of people who are already doing pretty well technically. Achieving a less than 15% change failure rate is very good. Less than 30% is also pretty good. So yeah, so this is interesting about the spread of people we've got in this session. Those were the 4 key metrics from the Accelerate report. There is another metric which is relevant for some organizations, which is availability. But I didn't include that because it's not relevant for everyone, and it's not entirely obvious how to measure it always, or what values you're looking for. So anyway, those are the 4 metrics. So now you've got some idea what they are. It maybe makes more sense to look at this. So this is a picture from the 2019 research report, and it's showing the distribution in their data of how good people are scoring on these metrics. So they've done a cluster analysis. So they've just looked at the data and found that they found a group of, in 2019, 20% of the people who answered the survey had very similar answers on those 4 metrics, and they are classed as elite because they have very good metrics on those 4 numbers. And so they've managed to cluster the data by similar responses. And you can kind of see from this that they've got a lot of data about high and elite performers, which is very good, but it's not a normal distribution. So it's not really a random underlying data sample. I think you can also conclude. But they have got a good amount of data about these really, really effective organizations, which is interesting. So then you probably want to know, well, what are the numbers? What are these elite organizations achieving? Basically, they're all at the top. They're all got all of the metrics at the very top of the spread. So the elite performers are deploying multiple times a day. The lead time is less than a day. The time to restore service is less than an hour. And they get a change failure rate under 15%. And that's a huge contrast from the low performers. I haven't put the medium and high in here because they're in between, and I didn't want too much text on my slide. But you can always look at the report and see for yourself. The low performers are in a completely different league, basically. And I find this very interesting that there's such a huge spread in organizations in the industry. And I think the lesson from this research, if you find that you're not in that elite or high category, I think you probably need to be a little bit worried, actually, because I think there's probably other companies competing with you who are in your same industry sector who are probably getting elite performance. And with those kinds of numbers, they're going to be doing really well in the marketplace, and you might need to up your game to compete with them. And even public.
Would you say that the difference between those has something also to do with like network effects of capability? So if you start doing better on one, it starts to automatically influence and improve the other, so that you can get a certain kind of jump, like a quantum jump.
So I think the thing is that elite performers are doing well on all 4 metrics. I think it's wrong you can't just trade them off and say, we're going to do really good on this one and not on the other. The cluster analysis is the elite performers are doing well on all 4. That's one of the myths that they busted in this research, that you can trade them off or that is needed. You don't. You can succeed on all of these metrics. The elite performers are.
I heard the question like, if I improve one, will it sort of drag another one along, another one of the metric? Are they correlated?
I mean, they are related because they're related to the underlying practices that you're using, and changing your practices may impact more than one metric. But I think it would be wrong to try and focus on improving one and thinking that the others would automatically come along too. That's not how to interpret this data. So thanks for those questions. I would like to carry on talking more about what behaviors are driving those metrics. And that is the next part. But before I talk about the behaviors some more, I'm going to give you a chance to discuss. If you had great results on those metrics, why do you think that is going to lead to organizational success? Because that's what the data shows, that the organizations that have great metrics on all 4 have more success in the marketplace, more success at meeting their goals. And that is directly being driven by these metrics, but why? So please go and discuss this in your breakout rooms for 4 minutes. So I hope you've had a good discussion about this question. Why would these metrics be important for organizational success? And I think there's many answers to this, and the research doesn't, I think, really speculate so much, but basically I think it's because these are measures of agility. They're measures of the feedback loops that you're getting. So this is a picture of feedback loops in extreme programming, which is an agile method. And the point of this picture basically is that these are concentric feedback loops. The release at this stage of when XP was being developed, months was a fast release plan. And all the concentric planning goes smaller. So if you're going to be successful at releasing it months, they were like, well, you need to have iterations of weeks and acceptance tests every few days, and all going down. But the metrics today are that these elite organizations, they've shrunk these feedback loops so much that they're getting new code out daily, and they're getting feedback from customers on the scale of days, and then they can respond to that, and they can build a better product and take advantage of that incredible ability to swing direction and be agile and follow the market and follow the money. So that, I think, is why these metrics are so interesting, because if you do well at them, it says something about how good your feedback loops are, your agility. So now, right, let's go and talk more about the behaviors that can help you to achieve this, this technical agility. So I've put this picture here, which is what I'm going to talk about from the research, some of the factors that really are important. There are actually more things in the research which not going to bring up. These are the ones which I think are particularly relevant for technical agile. And I'm going to start by talking about the generative and safe culture and the empowered teams, and go on to the other topics. So these are the headlines of what's really important to get right in order to achieve this metrics. So generative culture. Now, you can measure culture. And that was a bit of a surprise to me, but there are people who study this for a living, and Ron Westrom is a researcher who has looked at organizational culture. He designed this model, and it predicts organizations who are going to make products with better safety outcomes. So the organizations he was studying weren't necessarily software organizations. I think they were mostly medical devices, actually. But it turns out that the Accelerate researchers could use this model and apply it to software companies and discover the same result, basically, that if your company has a generative culture, that predicts success and predicts good metrics. And I'm not going to go into a lot of detail about what this is actually, but it's the basis of a generative culture is that the leaders are behaving in a way that promotes collaboration, promotes people taking responsibility, and promotes innovation. And it's a great way. It sounds like a great organization. And I think from the organization I work in, ProAgile, we've achieved this kind of culture. And it's not something that just comes for free. You have to work at it. And again, leadership is really important. But a lot of us are working in software development teams. So I wanted to move quickly actually to the next aspect that turns out to be really important. Software is built by teams, cross-functional empowered teams. And this is a key idea in basically all agile methods. So this is probably not so new to you, but it's worth realizing that this actually is important. Software is built by teams, and the culture of those teams is also important, not just the culture of the wider organization. So the Accelerate research, they looked at some research that was done at Google into their teams, and they attempted to replicate it more widely. They wanted to find out whether this research only applied to Google, or whether it applied to software development organizations more generally. And they found that, basically. So the Google research was looking at what factors make teams successful. And they came up with this list, and I've put psychological safety, dependability, structure and clarity on this slide. There were like 7 factors they found, and you can go and have a look at that research. It's really interesting. But this headline basically is that the biggest factor in your team is not how smart the individuals on your team are. The biggest factor is whether those people can perform to their best ability because they feel safe psychologically and they have good teamwork. And, you know, this is really interesting. Team culture is actually a really big factor. So at ProAgile, we've got this whole program actually to encourage great team culture. And I just wanted to put up this screenshot of our website where we've got this whole free available team development framework that you can look at. And I hope one of my lovely assistants will put a link to this page in the chat in case you're interested, because this is really part of it, getting teams that can work effectively together. And so just bringing this back to more technical practices, I'm a great proponent of ensemble working, which is also known as mod programming. It's where you get a whole team of software developers writing code together, and there are some structures and roles and facilitation to make this way of working smooth and productive. But it's about getting that team to produce code all together and get the best out of everyone in that team. And for this to work, you need to have a really strong team culture and collaboration. And this is a key part of the Saman method, which I've just published a book about Saman coaching. And working in an ensemble with teams is really, for a coach, this is basically, it gives me superpowers. This means that I can get together with a team, and if they already know how to collaborate well together and feel psychologically safe with one another, that means that I can come in as a coach and we can start working together. We'll take a realistic task, something that would be from their backlog, that would be ordinary for them working in their production code, and we'll work on it together, and I can help them to apply agile techniques and practices on that task in their production code base. So ensemble working is a really powerful mechanism for producing great code, but also as a coach, it gives me that opportunity to then start raising the technical competence of that team and showing them how to use techniques like refactoring and test-driven development in their real situation. So that was just I wanted to mention that this is a big part of what I do today as part of my work, is working in an ensemble with teams. And if that team already has a great team culture when I come in, that is such an advantage. So I'm interested in what you take on this. What technical practices do you think are important for psychological safety and empowered teams? So I'm thinking, well, this all sounds a little bit fluffy, of teamwork and stuff. And this is supposed to be something about technical agility, but I think they're closely related, and I'm interested what you think. I'm going to talk more about, so we talked a bit about generative culture and we talked about empowered teams. And now I want to talk about lean product management. I mean, I promise I'm going to get more technical soon, but I think this is really relevant. And you've all been discussing what are these technical practices that are important for achieving these metrics. And lean product management is a big thing, actually. And I think it has a definite technical element to it. And this is described in the research as, you're doing lean product management when you deliver features in slices that are sliced to be able to be delivered in less than a week. And you actively seek and use actual customer feedback. People who are using those features, you have to really go out there and try and find out what they think of them. That may involve talking to them, or it may involve just monitoring how they use it, or something like that. And then the next part is, of course, that the team can actually create and change specifications during development. They can act on that feedback that they gathered. So this is an engine for innovation, and it's at the team level that the team is able to decide what to build based on how well it went from the last thing they built. And this is definitely an organizational practice and a product management practice, but there's got to be a technical aspect here to how are we gathering that feedback? How are the developers going to act on that feedback in the way that they design the architecture and the code to enable this kind of really fast iteration on features. So I think that's interesting. And there's loads more to say on that, but I want to move on to some even more technical parts, which is the modular architecture, which also came up in this research is very important. The best organizations have modular architecture. And this is something we've known about basically forever in software, that this is important. You need to have a modular design. So today all the rage is, you know, microservices and using Docker or whatever and Kubernetes and all this stuff. And that's great. And that's a way of decomposing a large application into smaller pieces, just in the similar ways that in like the 70s, they were doing structured design and realizing that you need to divide up your large thing into more independent modules. And of course that there are differences. I mean, but I just want to point out that this is a fundamental idea. You have to have architecture. That doesn't go away. And in fact, it becomes even more important if you want to achieve team level lean product management. So I'm getting ahead of myself here. Saman coaching, this is the way I work now. And I've wanted to say a little more about Saman coaching. Because if you're going to achieve this modular architecture, you have to have a design that's modular, and that kind of, it's like turtles all the way down. You've got these modules that at an architectural level, but also at the more kind of class and function level. You've also got units and encapsulation, and you need to be good at design at that level in order to be successful with design at the larger level. So when I'm coaching, some of the skills I'm really focusing on are refactoring to enable you to iterate towards a good modular design. Unit tests to give you the feedback you need to know whether you've made safe refactorings, and testable code, testable design. Modular design often is testable. They're very similar concepts actually, testable design and modular design, but there are some, you know, you have to think about it. It's good to work out what differences there are. So these are some of the topics that I'm coaching developers on at the smallest level of the code, knowing that if they get it right there, it's going to be so much easier to get the larger modules of the architecture in place. So the modular architecture is defined in this research as meaning that the team, we're talking teams again, can make large-scale design changes without detailed coordination outside of their team. They can deploy on demand and they can do their own testing. Now, those are quite stringent demands on your architecture, but it means that you get this effect that the team can have an ability and a mandate even to deliver their changes to the customers without having to wait for other teams and wait for approval from outside the team. They have this mandate. So that means that the engine of the innovation in the team means that they can get their stuff out to the customers, find out what the customers thought of it, and change their mind about what to build next based on what they find. And it's a deeply architectural and technical problem to get this done, but it's also organizational. So one thing they highlight in the research, this is one of those pitfalls, that some organizations that are lower down, that have less good performance, are the ones that have these change approval boards or equivalents, where the development team basically needs to get their changes approved by people outside the team before they can deliver it to the customer. And this clearly in the research is shown as being something that damages your performance. The change approval board, people outside the team are not invested in the functionality. They don't, because they're not in the team, they don't necessarily understand what the team is trying to achieve, what they've done. They're making decisions based on less good information, and they are going to unnecessarily slow down the team. So what the research talks about then is that the really successful organizations, they might still have people outside the team in this kind of role that are supposed to check that everything is going to go well with the team's release. But their role is strategic as a process architect, an information beacon. They are not gatekeeping. And these successful organizations have this, the change process, the process by which changes get to customers is transparent, it's explicit, and it's easy to do the right thing. So this is quite a different way of organizing things in these successful organizations. But there's more, there's a bunch more stuff which I want to talk about to make that possible. And I want to know what you think. What would it take in your organization to give teams a mandate to deliver independently to production without waiting for approval from people outside the team? So please have a good discussion in your breakout rooms about this topic. Good, so welcome back everybody. I think all the rooms are closed now. So I hope you've had a really good discussion about this topic, because it's like for an organization that's not doing this, it looks really scary. And it's like, well, how would you ever trust a team to deliver all the way to production? We have really important customers, and how would they ever really respond to this? Well, the elite organizations that have achieved this, they're doing, let me just see if I can get it to change slides. Right. So the last topic that is really important from this research is continuous delivery. And that is the really technical part, which makes it in some ways safe to allow teams to deliver all the way to production. So continuous delivery is defined in this research as, well, teams are able to deploy to production throughout the software delivery lifecycle. There is not a particular delivery phase or window or deadline when we expect to deliver. Delivering is a normal part of daily life in these companies. It's not a delayed for waiting for something. And of course, the team always knows the current deployability status. And if the system is not currently deployable, they will act to fix that. That is their highest priority. So this is making deployability one of the primary concerns of the team, and being able to do that. So that's, again, this is technical. This is difficult to achieve. There's technical stuff, but it's really good. When you get there, you find that you get really good at doing deployment because you do it often, which leads to reduced pain around deliveries and less burnout. And if you're like me, delivering software this is great. This is what I want. I want to have really unstressed, calm deliveries, and I don't want to burn out. And those are really good, important results for a company. So they've got this kind of diagram in this research, and I've summarized it a little bit. But here on the top right, you can see the meeting the organizational goals. That's goals in terms of market share and profits and all those financial things that managers care about. So that we want that, but we also want the less deployment pain and the less burnout, which also are driven by this continuous delivery. And continuous delivery, of course, is it's those two properties I just mentioned, but that is being driven by a bunch of technical practices. And there are a lot of them. And depending on exactly which version of the research you read, the different reports from different years have slightly different practices. So in this presentation, I've picked out ones which I think are particularly important and relevant. So automated deployments, you really have to work on that and make sure it's just push of a button. But then there's these other parts which maybe need a little bit more thought. Continuous integration, continuous testing, loosely coupled architecture, automated security, database agility, and there's more which I haven't listed. When I'm looking at the kind of coaching that I do, Saman coaching, it's really impacting some of these technical practices more than others. So in my work, I'm quite focused on the ones I've highlighted here. And I'm going to talk a little bit more about those ones in the rest of this presentation. So let's talk about continuous integration. And I'm sure you're all familiar with the idea of a delivery pipeline. And I've drawn a picture here of a delivery pipeline, starting at the left with commit, code is committed to version control. Then it gets built and tested, and then it becomes a deployable component. It's a candidate for release, but before we deploy it to production, it needs to go through a battery of more tests, and system tests, load tests, acceptance tests, and then if it passes all of those, then it might end up in production. And this is some kind of automated sequence of steps that runs regularly. So continuous integration is basically defined as the pipeline runs green to this point at least daily. So every commit, we run the pipeline at least to this point, and at least one of those should be green at least daily. And then the rest of the pipeline you might run slightly less frequently, not maybe on every commit. But continuous integration is basically this first part. And I know a lot of organizations that have invested in building these kind of pipelines, and I think that's great. And I know that a lot of them are monitoring these kind of statistics. How often is it green at this point? And that's great. But I want to just remind you, really, continuous integration is not primarily about whether you've got a pipeline. The primary measure of continuous integration is actually how similar is the code that everyone is working on? Have we integrated our work together recently? So if you go around your development organization and just take a snapshot of the exact state of the code that they've got on their machine and compare it with everyone else's machine, you should find that there are very, very few differences if you are doing continuous integration. And that is what this means. And I look around a lot of organizations and find that this is not true, that people have been sitting in a branch for days or weeks. They haven't synced fully with the rest of their team or with the rest of the organization. And they may have a pipeline that's running green regularly, but nobody's pushed anything to it for ages. That is really what we're talking about here. We need to make sure that all of us are working from the same starting point, because software is always building on other people's work. It's always building on what you had before. It's important that we're all building from the same foundation. So that brings me to another one of the important practices in continuous delivery, which is trunk-based development. And that basically means that we are not having any feature branches that live for more than perhaps a day or so. All the developers are basically synchronizing their work together in the same branch, the trunk. And this means that you've got to slice your work into small pieces so you can share it often. That means that developers have to change the way they work minute by minute and actually commit and push to master and pull from master like very, very frequently during the day. And this is one of the practices that gets the most pushback from, because it changes the way a developer works. This has the biggest impact on a developer's day and how they spend their time. Well, the biggest impact. It is a very big impact. And this is something that developers find that, well, they think, well, it doesn't feel like it's productive. It feels like it's much more productive if I have my own branch that I can sit in for ages and do my own stuff. But that is not what matters. Software is built by teams these days. So that's a big part of the Saman coaching that I do. I realized that I already mentioned about the ensemble working, also known as mob programming, where we get the whole team together. And I coach in this context and help the team to learn to break their work into smaller pieces, to get that regular rhythm of, right, we're going to commit now, we're going to push to master, we're going to sync. And that is how you raise the team productivity, learning to break the work up and prioritize the team productivity over my individual feeling of control. So that's a big part of my work at the moment. The next thing that I want to talk about in continuous delivery, after continuous integration, is testing. Now, testing is also really important here. And there's a bunch of things that testers need to do, but I want to focus here on what developers need to do in continuous delivery. Automated tests are primarily created and maintained by developers. And that's not just unit tests, that's all the automated tests. Automated testing is fundamentally, this is code, this is a coding project, and developers know how to write code, so therefore they should be writing these tests. Of course, they collaborate with testing specialists. That's part of being in a cross-functional team. Of course, they informed what tests to write by collaborating with others, but the technical responsibility for writing them rests with developers. And therefore, of course, they need to be able to fix failures with their own development environments. Another pitfall I see happening out there is that the company invests in a fancy testing tool, and they only buy enough licenses that only the testers can use it. Or the license is so expensive that only the testers get them. And that means that the developers are then shut out of developing those tests. And that's a disaster for agility. It may have good other benefits, possibly. It might work for you, but it's not going to lead you to continuous delivery, I don't think. Developers have got to be involved in all of the automated tests. And then this last point from this research is that one that really makes me happy is that developers are doing test-driven development. And that's correlated with success of continuous delivery, or it drives the success of continuous delivery. So I'm guessing you might have heard this term before. Test-driven development's been around for a while, and it's usually explained as, we're going to write a failing test, we're going to see it pass, and then we're going to refactor, and then we're going to go round this loop. And I do demos of this. I'm sure you may have seen the demo of writing a little test, getting it to pass. And this is the heart of iteration, technical practice of iteration. And it's not that easy to learn. And you can make it sound really easy when you describe it like this, but actually it's a very different way of working. And I like to explain this with an analogy to skiing. So I don't know how many of you have done skiing, but it's a really fun activity. So I hope you've given it a try sometime. So this is two pictures of people skiing. Now, the one of them is a beginner. She's looking at her feet, so you can tell she's not very experienced. But she's got her feet wide-spaced in this snowplow configuration, which is a technique you often teach beginners because it's very stable. It's a very good way of getting down a gentle slope in a controlled way without falling over. And it's useful even when you're an experienced skier. You'll probably still use this in the right conditions. But the other picture is of the really experienced skier going really fast. And he's using a completely different technique, which is called parallel turns. And it gives you a lot more braking power, but it's quite different. You can see the skis are next to each other, and he's using both of them to brake with on the same edge. And it's a completely different balance. And I don't know if you've ever tried this, but I have. I got the hang of snowplow quite quickly, but then transitioning to this other technique was actually really hard because you had to relearn so many things that you could already do. And it's so tempting just to go back to what you know already. So if I relate this to software, test-driven development is like the parallel turns. It enables you to be agile and go faster, but it's a completely different way to build software compared with probably what you learned. And they're all the techniques that you already know. And it's so tempting just to go back to how you already know and give up when the going gets tough. So this is another big part of my work at the moment in the Saman method, that we have this learning hour where we are introducing new concepts and techniques like test-driven development, and we're practicing on exercises, beginner slopes. When you're trying to learn a skiing, you don't go to the top of the biggest, steepest, hardest slope. You find a beginner slope to practice on. And you find a bunch of friends to learn with. A skiing lesson is a chance for a group to all pick up the technique together. And that's really the picture I have in my head when I'm trying to put together a learning hour for a group of programmers. This should be like a fun skiing lesson. We're learning new techniques together. It's safe. We're going to do little exercises, beginner slopes, and talk about what we learned. I'm a great fan of these active learning techniques, which Sharon Bowman has written about in this book and other books. It's realizing that the way people learn is by making it experiential, by making it interactive, by making it fun. So that is really the basis of the learning hour that I do with teams as part of the Saman coaching. So as I mentioned, there are there are different kinds of slope that you might want to ski in. And sometimes the slope looks like the one on the left here. Beautiful. Oh, I'm really looking forward to my skiing holiday. It's just a few weeks away. I'm hoping to get some conditions like that. But of course, sometimes the conditions are different and you get a bumpy slope full of people. And if you've just learnt a new technique in your skiing lesson, like parallel turns, you might not feel very confident to use it when the slope looks like the one on the right there. And it's the same in your code. If you've just learnt test-driven development, and then you go to your production code base, and suddenly there's loads of other people writing code there, and it's really hard. You need mocks, and there's all sorts of dependency problems, and you might just give up, you know? So this is where the other part of the Samhan coaching method comes in, which I talked about before with the ensemble working, where the coach is with you in your production code. It's like having somebody to guide you down that slope. And once you've been down it a few times with the coach, maybe you'll feel confident to do that yourself. That's the ultimate goal, that the team should be able to deal with these conditions and to improve these conditions. And maybe the skiing analogy breaks down there because they can actually smooth the slope as well. There are techniques for that. So the Samhan technical coaching that I do is really focused on these areas. Writing better unit tests, iterative and incremental design, safe refactoring, continuous integration, and doing that a team at a time, because the unit of software delivery is the team. And I've put red, green, refactor there because you can kind of relate these to test-driven development, that they're the parts of TDD. TDD is a really complex skill that's made up of all these different parts. And that's what we can do in the learning hour. We can break it down, practice the parts separately, make it possible to be successful and learn these techniques. So that's about the Samhan coaching. And I think it's about time you people got a chance to talk now. We've got a few minutes left. So I want you to think about everything you've heard about in this presentation, and what do you think is most interesting? What can you take with you from this research? But I hope you've been having good discussion about what you think is interesting about this, this research, this presentation. I've got a few more slides just to round off some ideas that from my side, really. So I think I'm going to continue now, unless anyone tells me we're still waiting for people to come back.
I think we're back.
We're back, great. So one thing I think that you can do with this research, these accelerate research and these metrics, is you can start measuring them, and then you can track these metrics over time for your organization and see whether they are changing, see whether anything you do has an effect on them. And it allows you to compare yourself with other organizations. And the simplest way to start gathering these metrics is just by survey, just the same as the original research. Just ask people to estimate these values. So that's, and then if you want to be a bit more systematic about it, you can put in place actual measurements. So that's a good thing to do. The other thing that's in the Accelerate research is that they talk about what kinds of transformation strategies actually work, how to do that Agile journey, what kinds of things will take you forward on your Agile journey. And I'm highlighting a couple of things from the research that I think are particularly good. The communities of practice, where you make sure that there is a forum in your company or between companies for people who are doing the same job role to discuss the way they work and to share with one another. Well, I tried this and it worked, or I tried this and it didn't. So you're trying to promote a culture change by getting together these people with a common interest to share how they're succeeding. And then the other thing that I wanted to pick out from the research was an idea called proof of concept as a seed. And that means basically you try and get one team to be really successful and to apply all of the techniques and to do everything and to be a really shining example. And then not just kind of getting them to explain what they've done, but also to use them as seeds to transfer that way of working to other groups. So that they take their knowledge and ways of working with them when they go to a new team, and then that way of working spreads in the organization. So that's also been shown to be an effective way to spread new practices. And of course, it's nothing in the research about Saman technical coaching, because this is something that is fairly new, I guess, on the scene. I wanted to summarize the whole of Saman coaching, which is the way I work now to promote technical agile practices. I work with a team at a time, the whole team together. Every coaching day, we will have 2 hours of ensemble working together in their code base. We will have 1 learning hour where we go through exercises and have that skiing lesson. And I do these in blocks of 10. So a team will get an intense period of 10 coaching days, and then they take a break from the coaching. So that's absolutely deliberate, because the team needs some time to practice themselves. Just like between skiing lessons, you go and do some skiing by yourself. You know, you have to actually put in some work yourself if these skills are really going to stick. And then you come back to the next coaching day equipped with your questions and what's not working. The other part of the Saman method I wanted to mention was the team chartering, because I found that you can't, well, you can, but it's less good if you just jump straight into the coaching with a team. It's really much better if the coach gets to know the team first through a couple of kickoff workshops. And that's where the coach can really learn about the team situation and agree with them what topics and goals the coaching should have, and persuade them that this is something that they're going to enjoy and it's going to be good for them, and they're going to want to do this because they're going to get a lot out of it. So that kind of persuasion before the coaching starts, I think, is important too. So I'm nearly done. I wanted to go back to this slide, which is one of the first ones I presented about these 3 common problems that I see in development teams, and just highlight how Saman coaching helps to address these problems. So if you're struggling with poor quality code and people are talking about a rewrite, I think what you probably need to get out of that situation is skills at safe refactorings, skills to create unit tests and other kinds of automated tests, actually, that enable you to gradually pull yourself out of that bad code situation. So if you've got the second situation where you've just got loads of bugs, the solution is similar. You need better unit tests and better automated tests. You also need techniques for iterative and incremental design, because a lot of those bugs are coming from mismatches between the understanding of the code and the actual code. And that comes from the design not being updated and improved and modular and testable and all of those things. So I would advise a lot of learning about design and testability and doing that iteratively. Then there's the team that's struggling with never meeting any deadlines. And I think that a lot of that, they're not managing to coordinate their work. They're not managing to slice their features. They don't have the technical design in place that allows them to work incrementally. So continuous integration, iterative incremental design are really what they need to learn in that situation. And all of these are topics that are highlighted in Saman coaching. And the idea is that you level up the whole team together, that you try and get the whole team to start adopting all of these new technical practices, because the unit of software delivery is the team. So if you're interested in Saman coaching, I've just published this book. It's available on LeanPub, and shortly, very soon now, there's going to be a paper copy available, like in Amazon and stuff. I'm just finalizing the files for that. So hopefully within the next week or so, you'll be able to purchase a paper copy if you prefer that. Otherwise, the electronic copy is available now. So just to summarize this whole presentation, we've been talking about technical agility, pitfalls and secrets of success. And we talked first about these common problems that I see in teams, and maybe you recognize them, maybe you have your own problems. But I think they're quite common. Accelerate research gives us some metrics that allow us to measure how well we're doing and see progress and measure ourselves against other organizations. Then we've got this whole piece around what's really important in software development is cross-functional empowered teams, and the modular architecture to actually allow them to be working really independently and producing great software. Then there's the continuous delivery piece, which is a bunch of technical practices that we went through some of them. And test-driven development, I think, is a big part of that, continuous integration, obviously, as well. And then we talked a little more at the end here about the Saman coaching method, which is the method I'm using now, and some of my colleagues too, and people around the world picking this up. So it's a method for promoting technical agility. And I hope that if you're interested, you might look at the book or read up. You can follow me on Twitter, and I've got a Twitter handle, actually, Coaching Saman, with more information there as well. Thank you so much to everyone for coming to this presentation. I think we're out of time now.
2 minutes over, but quite well.
Great. Glad you could make it. Okay, so I'll be in touch with an email with a link to the slides afterwards, so watch out for that.